So far, all of the variables we have been using are value variables. That is to say, if we create the variable int x equals 5, this variable has a value of 5. So what is actually happening when we declare int x equals 5? Well, we have our computer's memory. We'll represent that with these brackets. And all of this memory is available for us to use. So I'd create a variable x, and I say that it is an integer. Now, an integer, and every integer, takes exactly the same amount of memory. So when I declare int x, it reserves a section of memory to store this integer and be referenced by the name x. Then when I say equals 5, it uses this space to store the value 5. And that's what I mean when I say that this variable is a variable of value. When referenced, it'll give us the value stored in this location of memory. But I can also refer to the location of memory itself using what is called a pointer. Creating a pointer is actually very similar to defining a value variable. And in contrast, a pointer is called a reference variable. So if I create int asterisk x, that is a pointer, but I need to give it a different name from x, so we'll call it y. So this asterisk is called the dereferencing symbol. And that name is a bit misleading because we're actually creating a variable of reference here. I'll get into that a little bit more in just a moment. But unlike my variable x, I cannot directly put the number 5 into this memory address. And that's because y refers to a memory address. And saying that memory address is 5 doesn't make sense. Memory addresses are not integers. In order to actually put a value into this memory address, I need to do it slightly different with a keyword called new. And I can say new int 5. And this creates a new instance of the integer object holding the value 5. So I can put a 5 into the memory address of y using the new keyword. Now there's a whole tutorial on the new keyword in and of itself, but for now, we're not going to go too deep into that. So I'm going to add a print statement here. And I don't really care what it says because I'm not interested in actually printing anything. I want to put a breakpoint in here and actually show you these values. So if I hover over x, you can see that I get 5. Whereas if I hover over y, you can see that I get this memory address rather than the value 5. We can expand it to see that it's holding a value of 5 in that memory address, but this y itself refers to this address, not this 5. Now, what if I want to take my pointer here and add the value stored inside it to the value of x? Well, I will again use my dereferencing symbol. So the dereferencing symbol takes a pointer and gets the value out of it. It's dereferencing it, turning it into a value. So I can say, well, let's do it here with the cout statement, x plus a dereferenced y, and this will output 10. As you can see right here, 10. So by using my dereferencing symbol, I can get the value stored in my pointer. Similarly, if I want to get the memory address from a value variable, I can use what's called the address of operator, which is the ampersand. So if I run this, you'll see that it prints out the memory location of x rather than the value stored in x. I can do an interesting conversion here by saying that my pointer of y is equal to the address of x. And then if I print out the dereferenced y, or the value stored in y, it should print 5. And there we have it. So if this video was useful for you, please leave a like. It helps me grow the channel and it will help other people find the video. And again, if you would like to see these tools used in a broader context, I recommend checking out my Developer Diary series, where I am working long-term on big projects and actually putting these tools to use. So thank you for watching, I hope you learned something, and I will see you in the next one.